So we go for the example for this topic. So the question is given given an original system, okay, with this thing x dot equal to 0, 1, negative 3, negative 5, x plus 0, 1, u, y equal to 1, 1, 0, x. And the same thing, the question asks you to use integral controller to yield the percentage overshoot equal to 10% and the setting time equal to 0.5 seconds. Okay. So as usual, we need to divide. We need to use this structure in order to design the integral controller. So you know that the structure is x dot x n dot equal to a minus bt. So firstly, in here you need to find a minus bt, and then here you need to find b a e, and then you need to find negative c, and then you need to find this one. You need to find a minus bk, bke, and minus c. So you know that. So we need to list out a minus bk. Okay. So our a is 0, negative 3, 1, negative 5, minus our b is 0, 1. Since this is a 2 by 2 matrix, so that's why we have K1 and K2. Similar with the pole placement controller. So finally you get 0, negative 3, 1, negative 5, minus 0, 0, minus K1 and K2. And finally you get 0, 1, negative 3, minus K1, negative 5, minus K2. So we put aside this information that the A minus BK is 0, 1, negative 3, minus K1, minus 5, minus K2. Okay, we put this information aside. Okay. Okay, now we proceed with to calculate the BKE. Okay, now we focus to calculate BKE. Right. So our B is 0, 1. Okay. The KE is always have one value, which is KE. Okay. So you get 0 multiplied with KE, you get 0. 1 multiplied with KE, you get KE. So we put aside that the B KE equal to 0 KE. Okay. And then finally, you need to find negative C. So the negative C, you have C is 1, 0. Right? So you just negative 1, 0. So finally you get negative 1 and 0. So your negative C is negative 1 and 0. So we have the information needed that we want to replace to the system with integral controller. So now I will convert all the informations to this structure. So we have x dot xn dot equal to 0, 1, negative 3, negative 3 minus k1, negative 5 minus k2. This is for the a minus bk. Okay, a minus bk. And then we have bke. Okay, bke is 0 and ke. So 0 and ke. Right? And then after that, we have negative c here. Negative c here is a negative 1 and 0. So So that's why you have negative 1 and 0. After negative c here, you have 0. So that's why you have 0. Right? And then you have x. Since our x is, you have x1 and x2. So that's why we have x1 and x2 for the first x. And then the final x is x and so here I need to do correction also. It's supposed to be have x1 dot because you have x dot 1 dot, x2 dot for the original system, and then you have x2 dot, and then you have xn dot. And then you need to plus with 0, 1. So it means that the rest, the top one always 0. Only the last row will become 1. That's the meaning of this one. And then after that, the y is negative 1, 0 because of the c value, negative c. And after negative c, you got 0. And then you have x1, x2, and xn. So this is your system with integral controller. So your task is you need to find what is the k1, k2, and k3 value. So it means that it's similar the objective for the pole placement controller. So the first thing that you have the original system, and then you need to refer to the integral controller with the system in state space. And then after that, you need to find all the values here. Then a minus bn, bke, negative c, so on, and then you have all the values here. And then after you have all the values here, and you will be placed to the state space with integral controller. And then finally, you need to find what is the value k1, k2, and ke. So that's the process for you to design the integral controller. Okay, so in order to find the k1, k2, and ke, so as usual, similar to the pole placement controller, so you need to refer to this information again. Okay, if you still remember again, same thing. Okay, so based on this information, the percentage of the shoot you will get zeta. Okay, and then after that you use the TS to get the TS or TP. I need to check the question again. The question is TS. TS or TP, I need to check the question again. The question is yes. The question is TS. So then based on this you get the omega n, and finally you apply s squared plus 2 zeta omega n s plus omega n power of 2 equal to 0. And I believe finally based on this you get s squared plus 16s plus 183.1 equal to 0. Okay. However, if you look at here, this is S power of 2, second order system. And then the state space here is a third order system. So you cannot compare between second order and third order system. Alright? So how we want to make sure this one can comparable with this to find the k value. So we need to add another third pole. Okay? So that's why s squared plus 16s plus 183.1. We will add the third pole very far away from the dominant poles. So let's say if I use calculator, equation 2 degree 1 16 183.1. Our poles is, so based on this our poles at negative 8, negative j10 here is positive j 10. Okay. So we need to add the third pole is much more farther from negative 8. So in this case, we can choose 10 times. 10 times farther. So it means that if 10 times farther, it can be negative 18. So we can put s plus 18 as our third pole. But if you choose 80, it's very difficult for you to calculate, isn't it? So it's easiest way, you can also choose any base post that greater than 80. And for others to you calculate, you can put 100. That will be no problem. So here the third pole become s plus 100 equal to 0. So it will be easy for you to calculate the value. So finally you calculate everything. S power 3 plus 100 s square plus 16 s square plus 1600 s plus 183.1 s plus 18310 equal to 0. 100. Okay. So by choosing 100, you don't need to use calculator. If you use 80, then you need to use calculator to calculate everything. So it will be a waste of time. So finally, you can get plus 116 s square plus 1783.1 s plus 18310 equal to 0. So this is, we can compare this equation, characteristic equation, to find the k value. So we put aside this information. So what we need to find s power 3 plus 116 s square plus 1783.1 s plus 18310 equal to 0 to find the k value.